Good morning, my students. Again, this is Professor Levi Akundabweni. And this morning, I am going to give a refresh on the SCSR 3781 plant breeding. And we are going to start actually in the middle at the point I presume we unfortunately had this interruption of the coronavirus. This figure that is displayed here is extremely vital if we need to understand plant breeding. It's a figure that I would like to use just for a refresh journey. It's a roadmap. And the first port of call here is a needs assessment toward what a farmer wants to grow for the market. And remember, the market is synonymous with consumers. And plant breeding to create a new cultivar is a business. It fits in the value chain. The P in the yeast bean pie is in essence the number one need or end that must justify the means by which breeders design a breeding program. Remember the saying that the ends justify the means. And that's very important philosophy in plant breeding. The second phase to this is developing breeding goals. And when you develop breeding goals, you do it on paper. It is like an architectural drawing that a contractor can use as a recipe to construct a building or a structure. At this point, it is what I want you to call as Plan 1. Remember, a breeder is both a farmer's architect and a contractor. The third phase has action-packed events and processes. They actually begin at phase 3. The actions involve assembling germplasm or even collecting it from the PGR ecology as the raw living materials for construction of plant breeding. Living since it carries the genetic adjuvant instructions that are embedded in their genetic variation. Remember, as we already have said, we are interested in the germplasm. Germ is living. In the germplasm, because of the variation therein. So the assembling of germplasm is a deliberate and very essential step in plant breeding, because that's where you want to harvest variation from, so that you can look at variants of choice to incorporate in the future plant breeding program. Then once this has been accomplished, it's very essential to study the reproduction of the germplasm of the particular species. Because germplasm here, which is the R system in the adhuma, it is the essential window that provides the means to manipulate the variation that might subsequently be adopted in the next phases of breeding. As you may know, reproduction is really the essence of creating variation. When you cross two things through a means of reproduction, the ensuing babies or progenies or offspring are usually varied, with some exceptions. Phase 5, remember I'm referring to this as phases: phase 1, phase 2, phase 3, phase 4, which we have talked about. Then when you come after the understanding on the reproduction of the germplasm, you can create a plant breeding experimental design. Consider this phase 5 as plan 2. Plan 2. At this phase, we now are looking at what we need to put in the field experimentally. Remember, plant breeding is taken as being both an art, because you have to use the breeder's eye, and a science. That's where then, like I said before, plant breeders don't work alone. It is a time when we may run to a biometrician to help us create a suitable experimental breeding nursery plan or design. So, creating the experimental design is where we now need a field manual. You walk to the field with it. As you plan the size of the breeding nursery, how to put the various germplasm lines you have, because you may have from 10 to 50 to 100 to 500 to 1,000. But of course, the forward thinking as we create the experimental design, which is in plan 2, we need to understand that we are going to want to collect data from the field, from the germplasm. Remember, the various germplasm lines are like the treatments. They are like the various factors. And they will weigh on the kind of variation differences that we expect. Those variation differences can be considered as the dependent variables on the germplasm. So what will make that possible is this phase 6. It is essentially a phase where predictive focusing is vital. Predictive focusing. Because you don't just collect germplasm from the field and then you have a variety. You need quantitative genetics to operationalize the breeder's favorite equation that we shall be looking at later. Without a prediction of genetic gain expected in a variety for a farmer, inbreeding is as good as a waste or a loss of expertise, time, and resources. Plant breeding is an expensive process, and that's why companies that do plant breeding to create varieties invest the expertise, the time, and resources to make a profit. So at this point, it is actually meaningless to proceed without knowing what is a new variety, what a new variety will show as a gain from the effort. That gain is called genetic gain. Then, after that, you can move to selection predictors. I like to call them the indicator functions. They allow for selection effectiveness and efficiency. A selection index at this point is a very useful tool of hitting two birds. That is to say, two or more trays with the same stone. And then what follows thereafter are steps to breed either for inbreds or for hybrids. And that actually follows this path until you come to a point of a finalization stage where then you proceed in looking at the various methods or schemes of producing new cultivars for farmers. I do hope that you will carry this understanding throughout in terms of the sequence of the rest of the lectures that we have left. Thank you.